So this is going to be the most boring talk of all the Plone conference, I'm going to tell you. I have no photos, nearly, a few. No great images. You will see a lot of great talks with a lot of images. And it's a bit technical, sorry, because I've been preparing this talk for the last 6 months. So there is some slides I don't remember. So sorry if I need to recap and just remember what I've been doing. So this talk is about Plone server. And I'm not going to introduce what is it until when I'm explaining. So just, it's something experimental, and it's a lot of fun. So I'm Ramon Navarro Bosch. I just add this slide because I'm Catalan, and I want to say that in all my conference. It's a small country in the middle of Spain and France. And I work at 2 companies, Iskra and Internetum, and I'm in the framework team of plone.org. And I'm a musician also, as you see. So this talk is not the framework team opinion. I'm in the framework team, but this is not at all the framework team. It's just a project that we started, and I'm going to explain it. But it's not any official opinion, neither a framework team opinion. So don't take me so serious. So why we started this project? This project started a lot of years ago in different Plone conferences. I remember in Brazil in 2013 that this guy you can see here, no, sorry, this guy here, with a caipirinha, was like asking to talk about what's going to happen on Plone 2020. And a bunch of people were grouped like outside of the building talking a lot. Oh, we should do that, we should do that. And all the developers said, oof, that's not possible. That's too much. Changing ZOP to pyramid, oh, we will never get that. Updating ZOP, oof, a lot of things, a lot of discussions to have. Wow, it was nearly impossible. So we had the same discussion on all the Plone conferences. And after being in all these discussions, and like an idea came to my mind to try to do something different to solve the problem of how we are going to be in Plone 2020. In all this conference, it's been also a lot of great talks. Why Plone will die, a lot of annoying, saying, oh, this is slow, it cannot scale. It's really hard for developers to come in. You have 20 different ways of doing the same thing, and you need like to learn all of them because some are only usable in some cases. So it was like a lot of problems and a lot of great talks in this conference. So this guy, Philip Bauer, that's seated down in the room, started to push everybody like, we need to talk about what's going to happen, and we need to discuss that, and we need to find solutions. But no solutions were coming up until, sorry, I don't have the next slide, so no, well. But we were lucky because there is these guys, Martin and all these, Lawrence and a lot of other people in the Plone, designed our content management, our dexterity in a really great way, in a really modular way. So from the architectural point of view and the design point of view, was really great to be able to evolve to different places. And that helped a lot in order to think where we can go in the future on Plone 2020. So there was a missing link on all this thinking about what's going to happen. And this guy, that's, I don't know where he's sitting now. Yeah, it's there. You can see there, Timo. Just take the suite as in the photo to build something that's called Plone REST API. That was our main important decision we did in, I think, in Bristol conference after like a game of deciding what's the most important feature for Plone in the next years. Martin like drive that session, and we ended that we need a REST API so we can provide integration with a lot of different things, and we can think about the backend as only an API. So he was like, we need to have this REST API. He's been working, documenting just installing Jenkins, and after installing Jenkins and documenting, he started to code 1 year later. But it's well done. It works. The REST API is defined. He's going to do a talk after mine. And it works. We have in Plone 5 a REST API that allows us to work with content, so we can decouple the front end from the back end. We can create our own JavaScript applications or whatever we want that attacks Plone. And we were starting to think, OK, then we have the REST API. We can start to think about a backend that only fulfills that REST API, nothing else. No browser rendering, not anything else that we are going to need from actual Plone. And we were thinking, is it possible to do that from scratch, just reusing the best parts? So we decided to call a bunch of Plonists that are friends. And one of them, it's Asko. For me, it's a hero, because meanwhile, he's doing Mosaic, and he's doing one of the best, most important components of Plone for the next years, is helping on the backend, on this plone.server, to provide a really good and a stable backend with a lot of good code and quality code. We also found Nathan, a JavaScript guy responsible of the mockup project, and it's been like on the community for a while now, and a really smart guy. He's also sitting here. And Eric Brihout, French guy, finally a French guy, close to mine. That he's also being really involved on front-end development, and he really knows a lot about Angular, about backend also. So we took all these people, and we decided to do a sprint, a really strange sprint in Barcelona. These are all also people who attended. It's the crew from my company. And we got 15 different developers, backend developers, API developers, and front-end developers together in Barcelona for a week, with no other goal to do experiment. Can we try to create a stack that it's similar to Plone, but without using Zope, building the front end in JavaScript only? And with that idea in mind, trying to tune the API to fulfill our needs, we spent 1 week, and we had really great results. It was amazing what 15 people can do, motivated in a room in the middle of Barcelona. The weather was really great also, so that also helps. So the three teams, the backend, the API team, and the front-end team, were working for 1 week, and we reached an experimental version of all the stack. And that's what we are presenting today. We are presenting, first now I'm presenting the backend part, our experimental backend part. Then the next talk, Tim was explaining the API. And the next talk, Eric and me are going to present the front-end part. So we joined the three talks to explain what we did this week there and the months after until now. So we tried to be friends, the front end and the back end. So we tried to have peace, talk a lot about, we need this feature right now? No, we don't need this feature. We need, for this basic implementation, experimental implementation, there is no content rules, for example. There is not a lot of things that we have in Plone. So we try to be happy and have peace between the two teams and just implement what's basic on a content management system on the front end and the back end. So in order to do that, we needed to see what is Plone. So we took Plone, this big monolithic piece of code, and we decided to break in different areas. We tried to fulfill all the areas that are in Plone core right now. There is theming, page templating, view-lets, portlet, pluggable authentication service, catalog, link integrity, the ZODB, content rules, nearly all the functionality that we have on, or the models, the basic models that we have on Plone. we draw them, and we say, okay, all these things that we have all together in CMF plone right now, how we can split them to make it a bit more peace on our mind. And it's a proposal of how to split these things. We say, okay, we have the front end, that's clear. So we have the theming, all the JavaScript, CSS history, all ZCC form and form libraries, page templating, views and portlets, now the tiles and the mosaic idea of the layout. So all these things are related to front end. So to rendering the content and to show the content. Then we took what we decided that to call the add-ons that are on core, more or less. The implementation of tiles, all the different pass plugins, query string, multilingual, workflows, the implementation of the catalog through the web restricted Python, link integrity, plone app discussion, version locking behavior, content rules, content types, and iterate, OpenID, and caching. All these are modules that we have in plone right now, but we didn't consider it as core. What we consider core? The registry, the place where we are storing all the configuration for our site, all the great history, the catalog API, and the pluggable authentication service API, the ZUDB. Without the database, we are not able to store anything. The generic setup story, just to install things. The UID, to say this object has this identifier. All the ZOP toolkit, and I created this white box here. ZOP2, access control, CMF, and acquisition. Why I did that? Because these are the parts that we've been discussing what we can do with this block of software. And because it's really big, a lot of people doesn't like acquisition, for example. It brings a lot of problems for newbies to understand, to learn, to security. CMF, it's like we are adding layer over layer over layers. If you see what's mosaic at the end, it's a behavior under dexterity, under CMF, and it's like, wow, we have 4 different layers to get to the object. That's too much. For newbies to understand what's happening in a piece of code, it's quite hard. So seeing this, and between the core, or all the backend part and the front end, we may have the REST API, and the core and the add-ons, the framework API that we call. That maybe would be plone API that we have right now, but at the moment that these things were developed was not there. So some of them could be rewritten to use this plone API, for example. So what happens if we remove this piece? Like anything works. So we decided to think more about using this framework API and create something we call server that does all the things that we had on this white box that we need to make everything work, but without anything else. So starting from scratch, this piece from zero. This is a bug. Okay. What we have here, it's one of the possible ideas that we have in mind about which is the possible future. That doesn't mean that Eric needs to follow what I'm saying. We have Plone 5 now. Plone REST API is on the market, so you can use it. So it's going to be on some Plone 5 release, assuming in core, if anybody flips it. Then at some moment, we will have Plone 6. And I suppose that the front end, because as you will see in the talk about JavaScript, building a front end or CMS generic front end is quite complex. And we have been dealing with a lot of problems, and it's going to be a long time. Meanwhile, we have this JavaScript front end to deal with the CMS, or different front ends to deal with different kind of CMSs. And at some moment, we may have another backend or multiple backends. Now, there is a group of people that is also working in the same problem, but instead of trying to create some new backend, it's trying to create ZOP4 to be able to evolve. And all the options are correct, just are different ways of seeing the same problem. And as Eric said in his keynote, I think that the best will be that at some moment we try to get the best from each of the sites, or maybe different servers for different use cases. Doesn't matter. So why I also pushed for plone server? We needed at work. I work in a SaaS company, and we have a really big SaaS product that creates, it needs a lot of interactions, a lot of integrations. It has a lot of, it works with big files, so we need to have a lot of input, output, and we also manage content. So I needed a backend that is scalable, that is synchronous, and that I'm able to use all the technologies that I already learned from Dexterity and from Plone. And we also have a lot of microservices, integrations. Well, and we tried, the first version was on using Plone, Zope backend, and we had a lot of scalability problems, and it was not possible to solve that solution in a short term, and we decided to try to build what we needed, and that's Plone server. So what's the idea? Collecting all the ideas, opinions of painting Zope Plone, getting the good features, and simplify. And the simplification, again the same. Can we take all the good parts from Plone with the REST API in mind and create a simple Plone backend? That there is only one way to do things, so developers are really focused, oh, this is the way to, I need to do that thing, so it's not, I don't have 10 different options. Trying not to be too much opinionated, so people can use this for whatever they want. So yeah, the answer is yes, that's Plone server. So we started, and we decided to use ZODB5, just recently released, and ZO5 that is implemented also using Async IO, and the Zoop toolkit as the basic. This is what we are going to have under our feet. And then what we're going to build on top of that. Plone server. So what's Plone server? It's an asynchronous application server that offers a traversable REST API with a ZODB. That's what is it. Nothing else than that, nothing more than that. It's an asynchronous application server on top of a ZODB that offers only a REST API. And on top of that, we can build the CMS that we need, the CMS entry points that we need to build to run the Plone client. So I'm going now to go to the technical stuff. Already, Eric still talked about what's a Headless CMS. I think there is a good talk about Headless CMS on the Plone conference. I suggest you to go. A Headless CMS is something that does not include the view part, the rendering part, has a strong and flexible API, and thanks to Timo, we have that. We have a database, a persistence history. We have ZODB, a really good persistence history behind that, and an option to manage and to create content with that API. How we started, we decided to start with the content types, and the content management system is the first thing. There is no CMF products at all. Everything is based on Zope container and Dexterity. It's only Zope container and Dexterity on top of that. So all the contents, there is only one content defined on Plone server. It's called item, and it's containish. So Philip will be really happy. So his flip is included on Plone server. How we are going to define content types, at least right now. Okay, I'm really not happy with the way that you can install or create content types right now. So what we did is you declare which content type you want to run in your application in the code, and you have that content types. It's not so much configured. You will see that there is no through the web ideas right now. Maybe we are going to add some extra feature for that. But right now, it's all designed to be declarative on the moment you are developing the application. So content types are global for all your application. And we defined the directives that we have on Plone to enable cataloging or indexing, read-write permissions, primary fields. Instead of having a catalog.xml that you need to install or you need to uninstall to define which are the fields that you're going to index, we define in the code. This field is going to be cataloged and it's going to be indexed and it's this kind of type of code. And I think I have an example. Yeah. So how is a content type on Plone server? I'm sure that you know interfaces from SOAP schema, create a text line, and you can define with a directive, this is the title is the kind of text. So it's going to be indexed as a text. And how I'm going to register this content type? I'm going to register saying which is the name in GCML, the interface, the class that is going to instantiate, and the behaviors that we're going to use, all in GCML. No option to create that on live. So it solves a lot of problems. It lacks some features. Another important piece of code that was needed is the serializer that serializes dexterity and schemas to JSON and deserializes that. So we created plone.JSON serializer. It's being used right now at Plone App Mosaic for being able to render the fields that we have inside the layout editor. Needs some merging with Plone REST API way of doing schemas. Yesterday night we solved most of the problems. But Plone REST API serializes schemas, FTI schemas in some kind of way that it's different of how plone.JSON serializer is doing. So we need to tune the API to be completely compatible. Plone registry. It's the, besides content type, it's the only thing that it's on the ZODB. I try to maintain the ZODB as clean as possible, there's only content and the registry for each site. So you can define which is the active browser layer, you can define the course configuration of your site, but not so many things. Which add-ons are installed, or which add-ons are not installed, but not so many things. All the information should be in the registry. So one of the ideas we are working is, for example, the CMS package on top of Plone server. All the actions, instead of having portal actions, are going to be stored on the registry. All the information from your site should be stored on the registry. That's my idea. I'm sure that we have a lot of discussions about that. So all persistent information that's not content, it's in one place. The other thing that we were thinking, okay, this Plone server needs to offer an API. But right now, nowadays, if you want to design an API, there is a lot of tools, Swagger, ArrayML, but none of them are traversal. You cannot write the API definition that it's traversable, as we are used on this traversal history. You cannot define, okay, I want for iDocument, these entry points or these HTTP verbs. So we needed to create our own way to define the API. Otherwise, we couldn't find any way. Framing. It's also important that when you're getting an object, you have the option to get also different related information to the object. WebSockets API. As we were moving to Async.io backend, we were able to offer the REST API through a WebSocket. So you can create content and delete and get content through the WebSocket connection. And all is based on Plone REST API and trying to fulfill as much as possible the actual Plone REST API. So how it looks like? It looks like that. You define the interface that you want to offer your API definition, and you define possible endpoints that are going to be tied to this content type. For example, at registry, the HTTP verb get is going to use this factory, and you need these permissions to use this factory. And of course, there is the main HTTP verbs for the content type. So if you delete a Plone site, you are going to execute this factory and you need these permissions to be executed. Simple. Just the factory, the permissions, and defining possible endpoints. And you get a JSON file where you have all your API defined. And you can extend on your own package. You can override it. There is browser layers to do that. There is a lot of other options that you can use it. Course. Of course, we are an API, and one of the most paining things on API is the course. We created that it's all course enabled. It's defined by site. Each site has its own course configuration. It's stored on the registry, and you can override just using the API to modify the plone registry. Another different concept, it's, okay, we are now in a REST API. I was thinking, I'm normally mounting different databases, different Zio or ZioDB databases on my application, different distributed or different amount of things. So the URLs are designed in a way that the first element is always which database are you going to connect, then which site, and then the object of the site. And that's a generic way it works for me. And how do you define these databases? So in the configuration of the application, you define which databases do you want to use. You know, you can see I love JSON because I'm using a lot of places. So you define, for example, this plone database. It's ZioDB, and it's on folder data. And this other database, Zio1, it's a Zio server, and the address of that Zio server is that one. So, and then I can point to this ZioDB / Zio1 / site / whatever. Traversal. Okay. I've been trying to review all the traversals we have on Zope, and it's quite, it's a really interesting job to do. But I tried to create a simple traversal that fulfills the needs of a REST API. It's not designed to render HTML. It's designed to fulfill the cores, to fulfill the needs of the getting an API result. So what we do, we get the resource that we are traversing to. We get the user abstraction, so we get all the security information from the headers, cookies, whatever. We do language negotiation. You know, I'm Catalan, so language is really important for me. So we implemented multilingual options inside the core. Then it checks access permission. So it checks if the user has permission to access the object itself. Then it looks up for the view that is going to render what is asking the user, traverse to the view, do the security checks of the view, looks which is the render that is going to be used to render that view execution. We implemented content type negotiation. So if you want, you can create your API definition that renders HTML, renders JSON, renders XML. So you get the content, and you can define different renderers based on the content type that you are willing to go to render. Then the transaction occurs. So you run you execute the view and the render, and the framing. You look for the needed framing options that you have on your API call, and then all the course checks, headers that needs to be added depending on which is the configuration and how do you define it are being applied. This is what Traversal does in this case. One of the things that with ASCO we've been trying to do is that, okay, get operations, head operations, and option operations on HTTP verbs should be read only. So you are not modifying the database in a get operation, or you shouldn't. There is a post, a patch, a put, a delete HTTP verbs to do writing operations on the database. So what we did, the get, hits, and the option does not have any transaction, does not commit anything. It just roll back anything that you do, is not going to be stored on the database. All the others has all the engine of transactions and how we're to make sure that they're going to be serialized to the database. So the request object, we are using AAO HTTP, sorry, AAO HTTP. So we have a compatible WSGI request object, and we added a lot of things on the request because I love Pyramid. So it's kind of way to add all the things that you need in the request object. So we have the site components with the global site manager. We have the plone registry. It's on the request by itself, so you can access it. There is the application root. There is the plone site that you are visiting on the request. All the security information about which users has been authenticated, which roles they have, blah, blah, blah. The object that you have traversed through your API. All the tail, the information that you are offering on your HTTP call. And then the ID of the database that you're using and the ID of the site that you're using. So we are like overfitting a bit the request object with all this information, but it goes fine. We also implemented some helpers like sub requests to do real request to APIs. Async IO, there is no problem about having multiple sub requests inside that because it's working fine. Then we have also do traverse that does the low-level traverse with asking permissions, so you are not getting any object that you don't have security to get. As for us, it was really important files because we are working a lot on files. We kind of implemented a upload download framework inside Plone server to work with buffered uploads and buffered downloads, so you can delegate to external services to store the file and to get the file on live, just buffering and never holding all the file in memory, neither on the server. It also implemented TOS support, so you with JavaScript clients you can have resumable uploads to any kind of backend. I will talk a bit more later about that. I think I'm pretty late, no? What time is ending this? Oh, 11. I need to go really fast. Okay. Configuration. There is a configuration file for all the application. There is the registry configuration for local site configuration and local components you can define for the site. And we created an easy way to create add-ons, like copying the old way of having an install.py file that you can define what it's going to do when you install and when you uninstall. And all it's being possible to be executed through the API to install and uninstall these possible add-ons. As I try not to be too much opinionated, all the user database and the catalog, it's not implemented on Plone server. There is only the interface to provide you a generic Python API to use cataloging and user lookup and pass authentication services. So you can implement wherever. There is no Z catalog right now. If anybody wants to implement that, they can use it. They can implement the API. There is no generic setup. As I said, we install add-ons just using Python file. There is no acquisition. There is no CCC form. There is no attribute traversal. So you need to go through dictionary traversing if you want to go to different sub-objects. Roles, more or less the same as Plone. Owner, editor, reader, anonymous, site admin, site deleter. Permissions, more or less as Plone. I just changed the name to make, but these are Plone roles. So there is no ZOP roles, as you can see. So there is a permission for read, write, configuration to unmount, to get a database, to mount a database, to delete portals, to get portals, add portals, see permissions, change permissions, access per flight for the course. Well, so I reduced a lot of packages. And to show that, this is like 300 different packages that we have on CMF Plone right now. I try to make them viewable, but it's impossible. So I was trying to do an experiment, just all these packages that we have here, which ones are in Plone server or not? So I started to remove the ones that are related to front end. So CCC form, Plone app theming, chameleon, all these things out of the list because I'm not going to render anything. All the Z catalog thing out of the list because I'm not going to implement catalog. R types, well, we can use R types if you want. Acquisition, datetime, all out of the list. And what we are going to include on Plone server, CMF core, ideas, 5ID. I'm talking about merging the ideas, not the code, of course, just what semantically is trying to implement. Traversing, local site manager, ZOP site, and access control. We are using ZOP security and ZOP security policies and Plone server security models to do the access control kind of way of taking control. But still, there was a lot of packages, so I still removed more packages that are front-end. plone.registry, ZOP browser, a big list. I also removed everything that is related to the specific content types that we have in Plone, because my idea was only to create one content type, and that's all. So all these things out. Sorry, Phil. And what we added, so browser layers, the interfaces for authentication service, multilingual, sub request, the text field implementation, global request, persistence, the quick installer idea, local roles, folder, CMF Plone, named file. And we ended having this thing. So what packages has Plone server? All these ZOP packages for the ZOP toolkit with ZOP 5, ZODB 5, and these packages of Plone. Plone dexterity, RFC 822, behavior, supermodel, alter ego, registry, 18N, UID, and indexer. And these are the packages that are still in the cloud that maybe needs to be moved to Plone server or not in the future. How transactions work? I'm going to go really fast on that. ASCO did a really great job. So there is only one connection to the ZODB. There is no multiple connection we have now for each request. And we have a locking system and a queue system that queues all the transactions in a thread. So all the transactions are serialized one by one in one connection. And we are refreshing the connection for each request so we get what's on the database. We can talk, if anybody was interested on that, I can go deeper there. Async IO loop, why we need async IO? Mostly because for us for scaling and integrating with different services and for dealing with a lot of input-output with external services and files, it was needed to scale it up really fast. And for us, the results were much better, and I'm going to try to show them really fast. There is an async IO queue implemented, so you can say, I have this view that I want it is executed, some operation, just queue it, and do it whenever you can. And it's going to be done, and transaction it, and you are going to be able to see the results when it's finished. So there is the main thread, there is the transaction execution thread, the queue execution thread, and the ZODB networking thread. That's more or less the schema that we have. HTTP is really fast, supports SSL by default, so you can offer SSL connections without anything over that. Supports WebSocket, creating your own custom router. It's Gunicorn compatible, so you can start it with Gunicorn, defining how many process do you want to execute. And you can also use the HTTP UV loop, the one that's using a Node.js, so it gets the performance increases a bit more. So you can start it for production, like scaling it really fast. It's only for Python 3.5 and up. We created a testing environment. So there is layers to test the application, only the application will all the engine running to test WebSockets. and all the API wrappers to reuse in testing. We created some add-ons we published recently. One is a OAuth like serve add-on that allows you to connect with some OAuth. Elasticsearch implementation, the catalog, it's delegated to Elasticsearch, all the catalog, and it provides you with security the same way that we have in Zcatalog. pserver gcloud storage, it's a way that you can define your bucket on Google Cloud Storage, and all blob files are going to be stored there. And pserver.cms, it's like the package that we are building to provide CMS functionality on top of Plone server. Performance, and I have a lot of graphics about that, so I'm going to go really fast. Just a standalone in a laptop gets 118, 19% more rapid, plus, sorry, I wrote that in Catalan. It means fast. So to 12 threads, 100 connections at the same time, it gets in a medium testing a lot of times. In a cluster of 3 computational units, and with UV loop and 2 processes, we get in read-only operations 170% more fast than CMF Plone right now, with Plone REST API, of course. Comparing exactly the same operation with the same results. There is a lot of graphics. Anybody wants them, I can show them. This is CMF Plone. This is Plone server. And this is in a cluster with 8 processors balanced on Plone server, an average of 18 microseconds for answer, with some catching also here. So I wanted to do a demo. I think I don't have time because I'm really out of. I can show. There is a repository called pserver.demo. We have a organization we call Pyrenees, just not to freak out everybody that it's in Plone. The Plone server is on Plone repository, but we have been playing all this experimental thing in the Pyrenees organization. And you have a pserver demo where you can download that and just play with that and see, add issues wherever you want. There is a lot of to-dos. As you can imagine, building these kind of things, it's not so easy. Security, we need a blobs implementation using ZODB blobs implementation, catching and memoize. We need to move some functions from HTTP verb to HTTP server to have more performance on parsing the HTTP headers. User database and catalog implementation. We need to join this JSON serializer with REST API, try to apply the Plone API if workflows are not implemented right now, and through the web API customization to decide what we need to do on that. My personal plan, because I'm going to do that, is we are going to release soon backend for Neo4j and to offer GraphQL query interface to the object of the database. And we are willing to have an option to create a DB on the Zio hot. That's something that is really hard to. You were trying to do that. It's something that we need to do. So we will need to invest some hours there. So now we are going to have a Plone API call and then Plone client call, a talk, and you will know more about this underlying and these ideas I've been explaining. Just to say that we are a community, we can have fun, and we should be proud about ourselves. And sometimes when we are dealing with Zope, I see a lot of faces like, Zope. And it's not because it's a bad technology. It's mostly because it's been there for a lot of years. So, and people are getting bored, or like we need new motivation and these kind of things. So this is an option. So you want to have fun, we can do that. I just wanted to show this photo because this was started on, I think it's Arnhem sprint, century sprint, anniversary sprint of 4 digits. We were called at the beginning Superlacker, this idea. And my question is just to you to think, and if you find me, just point me and ask me to answer. Who wants that is called plone.server? I have no problem to change the name, But if the community wants that this is called plone.server, it will maybe continue to call plone.server. Otherwise, we can name it another name, and there's no problem at all. Okay, so that's all. Thanks.